welcome back. Today we're going to be looking at displaying data and variables. Now, if you're performing any type of experiment, you know for a fact you have to provide results and evidence to your reader. Now, for today, we're going to show you how to select the right type of graph that can display this information better. Okay? So, there are three types of graphs that you look at. Line graph, column graph, and a pie graph. Now, line is also interchangeable with scatter, and column is also interchangeable with bar. Now, the reason why we're looking at these three in particular is because these are the most commonly used in science to display data, okay? Now, your experiment is nothing without properly measured results. So if you're looking at, say, a table of results and you want to make it easier for people to read and to see a trend, you need to select from one of these three. However, it can be tricky. So today we're just going to go over the basics. Now let's say you want to use a line graph. That means you need to have only numerical data. So that means that you can only use data that, for both variables, is measured with numbers. Sorry, pardon me. So on your y-axis and your x-axis, you're going to have these variables. Your x-axis is for independent variables. Things you changed on purpose. So for instance, you might change the type of fertilizer that's being used. You might change the mixture of oil in petrol for an engine. You might be changing how much salt you add to the solution. Okay? All of these are variables that you change on purpose to create an effect. Your dependent variable. Which is your observed. Okay? Now, it's important that you are able to identify these two variables, because if you can't, then odds are your experiment is inherently going to fail. All right? An experiment only works if we are able to have all other variables kept the same, except for these two. It's much like how a race only works if everyone starts at the same point and starts running at the same point to the same destination. The only thing that should be affecting them when they come in position is how quickly they can run. Same thing's happening here. So, if I'm looking at this and I'm applying this information, then my independent variable is going to go along here. So I have a title with units in brackets. Up here for my dependent variable, I have a title and units as well. And up here, I have a graph title. Now, if you're ever unsure about what type of title to use for a graph, a good old boxing match terminology between, one variable and another, time versus temperature, or speed versus friction, or color versus whatever, okay? If you have these two, you're instantly telling your audience exactly what you're looking at, and they can find a relationship between the two. Now, for a column graph, it's a blend between numerical and non-numerical data. So this means that we're looking at two sets of information, one of which is reliant on numbers, the other one is separated into categories. So for instance, if you're looking at speed at which cars travel versus the color of the car, or you might be looking at favorite movie genre, based on votes by people. Okay, each one of these has an aspect that can be counted and one that can't. The aspect that cannot be counted is the basis for the columns or the bars. Now, depending upon which way you look at it, more often than not, column graphs go like this. And so on and so forth. They have a bit of space in between them, which your maths teacher will talk to you about the finer points of if you ask them, or your physics teacher might say they don't really care either way, as long as the data's down. Line graphs have a single line or several lines that vary based on the position of data in them. Alternatively, you can have scattered dots, and so on and so forth. With drawing both of these by hand, it is crucial that you do this with a lead pencil and ruler, okay? A line graph, you are not going to be doing that with a straight edge because the line's going to keep shifting backwards and forwards based on the data. You do need a ruler to ensure that everything else is straight and neat and orderly, particularly with Bowman-bar graphs, I should say. You need to ensure that your presentation is on point, okay? You need to dot those I's, cross the T's, cover all your bases. For our pie graph, it's a little bit different. We tend to use numerical data here and non-numerical. But its main purpose is to illustrate percentages or fractions of a whole. Okay, the entire concept behind the pie graphs is showing how a single entity is divided into numerous pieces. So looking at the composition of air quality around us. If I were to look at that as a pie graph, nitrogen would be at 70%, oxygen about 20%, carbon dioxide 10%. Okay? The point is that it's illustrating how this large mass has been divided into several subcategories. Now, these three types of graphs can be done by hand relatively easily. The biggest thing is, can you do it on a computer? Now, there are two programs you can use. You can use Google Sheets, or you can use Microsoft Excel. There are others available, but these are the two big ones that people tend to come across. My advice to you is when you finish this video, go find a maths teacher, computer teacher, or science teacher, anyone in the STEM subjects, and ask them, can you help me understand this? Can you help me do that? But before you do that, you need to go in and say, I want to practice creating graphs. I want to practice getting better at this. If you don't feel comfortable asking your teacher, that's fine. Ask your parents. Ask an older sibling. Ask a cousin or an aunt or an uncle. Ask anyone who works in a field where they have to analyze data. And you're not going to be, limited for choice. A lot of jobs require people to not just be able to interpret this information, but to create it. Anyway, that's it from me. As always, I've been Forry. You have been amazing. I'll see you around.